everyone, my name is Rhea Marie V. Maguliano, a grade 12 STEM student of San Pablo National High School, San Pablo, Isabela. Ang Radyo Eskwela ang siyang naging daan upang lalo kong maunawaan ang aming mga aralin. Sa pamamagitan nito ay lalo akong naiengganyo sa pag-aaral sapagkat masaya ang pamamaraan nila ng pagtuturo. Nagkaroon ito ng malaking parte sa aking buhay lalo na sa aking pag-aaral at dahil dito ay madami akong natututunan. Ito din ay isang malaking instrumento na nakatulong sa akin upang maisakatuparan ang aking pangarap na makapagtapos ng pag-aaral kahit na may pandemyang nararanasan. Kaya naman masasabi ko nga sa Radyo Eskwela sa Isabela, patuloy ang edukasyon.
Senior High School On-Air Academy. Unstoppable! Delivering you quality education amidst pandemic.
To declare school opening to October 5.
Unstoppable!
Giving you accessible learning platform anytime, anywhere.
Ang klase, whatever form it is.
Comprehensible!
Buckle up and get yourself ready.
I will repeat, and you will do it later on.
Accurate!
The sphere that includes all living things.
Today, we'll be talking about rational functions.
Simplify.
This is Jaw speaking. How may I help you?
This is the School Radio's Senior High School On-Air Academy.
And now, here's your new episode for Numbered Ranks. Your guide for the subject is Statistics and Probability. Numbered Ranks.
Number trends.
Good day, young statisticians. Welcome to our radio-based instruction for statistics and probability. Your calculation, your solving skill. We are glad about your willingness to learn. I am Hensley R. Marquez, your teacher on air. I know that you're very excited about this vitalizing learning experience. So stay tuned and let's get started. Reminder, dear learners, before we start, first, make sure that you are in your most comfortable place to study and make sure you can clearly hear our today's broadcast. Oh yes! Statistics is the most commonly used branch of mathematics. We use it almost every day. It is also a must of knowledge for a data scientist. Central limit theorem is the cornerstone of it. Can you give me a loud hooray if you're ready to begin new learning?
Yay!
Class, do you want to know how to make inferences about the sample and population parameters? If you do, buckle up because we shall start your journey in statistics and probability after this break.
Now that we are in the new normal, let us practice new things. Observe social and physical distancing at all times. Disinfect our things. Let our temperature be checked. Always wash our hands with soap and water. Use hand sanitizers. Avoid crowded places. And always wear your face mask and face shield. Always remember these things because health is wealth. Let us beat COVID-19. A reminder from the Department of Health, Department of Education, and this station.
And we are back, learners. I hope everyone is ready and excited to learn because we are about to explore new ideas and knowledge in the world of statistics and probability, particularly in central limit theorem. Our lesson for today's episode will focus on 2 points. 1. The definition of the central limit theorem. And 2. The application of central limit theorem. Hence, you will be able to illustrate the central limit theorem. To start with, I would like to ask some questions. How vital is central limit theorem to researchers? Indeed, because central limit theorem teaches researchers to use a limited sample to make intelligent and accurate conclusions about a greater population. It also justifies the use of normal curve methods for a wide range of problems. Let's ponder the important context of the central limit theorem, which is comprised of statistical terms. To test your prior knowledge of the concepts, let's see if you have understood the terms by identifying the following definitions. Write your answer on a separate sheet of paper. Are you ready?
Oh yeah!
Okay, let's begin. Question number 1. What do you call the set that contains all data of elements, individuals, or measurements from your experimenting space? Precisely, it's a population. Let's proceed to question number 2. It describes the data and/or population and/or sample range and how data is spread in that range. What do you think is the answer? Absolutely, it's a distribution. How about question number 3? It refers to the average value of all data from your population or sample. Indeed, the answer is mean. Next is question number 4. It is a randomly selected subset from the population where the sample size is denoted by n. What statistical term is that? Certainly, the term is a sample. Let's move on to question number 5. It describes how spread the population is. What do you think is the term? Very good! It's a standard deviation. Lastly, question number 6. What do you call when the population is spread perfectly symmetrical with standard deviations around the mean value? That's right! It's normal distribution. Did you have fun, learners?
Oh yeah!
Let's go over the important concept of the central limit theorem. How do we illustrate the central limit theorem, learners? Precisely, central limit theorem states that the sampling distribution of the mean approaches a normal distribution as the sample size increases. This theorem says that regardless of the distribution of the population from which a sample is taken, we can choose a sufficiently large n so that the resulting sampling distribution will approach a normal distribution. In general, n is greater than or equal to 30 is large enough for the sampling distribution of the mean to be approximately normal. Now that we're done stating the central limit theorem, let's proceed to the concept of the standard error of the mean. How do we describe the standard error of the mean? Certainly, it measures the degree of accuracy of the sample mean, or mu sub x bar, as an estimate of the population mean, or mu. It is also known as the standard deviation of the sampling distribution of the sampling mean, denoted by sigma sub x bar. Given by the formula, standard deviation of the sampling distribution of the sampling mean is equal to sigma divided by square root of n, where sigma is the population standard deviation and n is the sample size. Are you ready to determine the standard error of the mean of the given set of data?
Oh yeah!
Class, let's consider the given problem. Suppose the mean and standard deviation of a population are 75 and 15 respectively. The sample size is 100. What is the standard error of the mean? In order to answer this, our first step is to identify the given parts of the problem, such as population mean or mu is equal to 75. Standard deviation or sigma is equal to 15. And sample size or n is equal to 100. How about our second step? Indeed, substitute the given values to the formula and then simplify. Therefore, the standard deviation of the sampling distribution of the sampling mean is equal to 15 divided by square root of 100 is equal to 1.5. Are you following me?
Oh yeah!
Now, let us have a run through using the z-score formula. Z is equal to x bar minus mu over sigma divided by square root of n. When computing for the probability that x bar will take a value within a given range in the sampling distribution of x bar, where x bar is equal to the sample mean, mu is equal to population mean, sigma is equal to population standard deviation, and n is equal to sample size. Did you know that?
Oh yeah!
Alright, let's start with a given problem. The average time it takes a group of students to finish a particular class activity is 39 minutes. The standard deviation is 8 minutes. Find the probability that 45 randomly selected students to take the activity. The mean time takes the group of students to complete the activity will be less than 41 minutes. In order to answer this, our first step is to identify the given parts of the problem, such as x bar or sample mean is equal to 41, population mean or mu is equal to 39. Sigma or population standard deviation is equal to 8, and n for sample size is equal to 45. Find P of x bar is less than 41. What is the second step? Precisely use the formula to find the z-score. Z is equal to sample mean minus population mean over population standard deviation divided by square root of sample size. By substitution, 41 minus 39 over 8 divided by square root of 45 is equal to 1.68. What is the third step? Certainly, use the z-table to look up the z-score you calculated in step 2. Z is equal to 1.68 has a corresponding area of 0.4535. How about step 4? Absolutely. Draw a normal curve and plot the z-score 1.68 in the x-axis and its corresponding area. Then, shade the part that you're looking for. P of x bar is less than 41. Since we are looking for the probability of less than 41 minutes, the shaded part will be on the right part of 1.68. After sketching the graph, what comes next? Certainly, add the corresponding area of 1.68 from 0.50. P of x bar is less than 41 is equal to 0.5 plus 0.4535 is equal to 0.9535 or 95.35%. And And what do you think will be our last step? Certainly, we will state our answer. So, the probability that the 45 students will complete the class activity in less than 41 minutes is 95.35%. Did you get it, learners?
Oh yeah!
Nice job! Your knowledge of the formula and manipulating the given data will be handy in solving this problem. Just follow the different steps to answer the problem by applying the central limit theorem. I'll be reading the problem. Are you ready? Okay, let's do it! The average time it takes a group of senior high school students to finish a periodical examination is 45 minutes. The standard deviation is 6.5 minutes. Assume that the variable is normally distributed. What is the probability that if 50 randomly selected students to take the periodical test, the mean time will be more than 47.5 minutes? We have to apply the same procedures. What is our first step? Precisely. Step 1. Identify the given parts of the problem, where x bar, or sample mean, is equal to 47.5, mu, or population mean, is equal to 45. Sigma, or population standard deviation, is equal to 6.5. And n, or sample size, is equal to 50. Find P of x bar is greater than 47.5. After the given, what comes next? Certainly, use the formula to find the z-score. Z is equal to sample mean minus population mean over population standard deviation divided by square root of sample size. By substitution, 47.5 minus 45 over 6.5 divided by square root of 50 is equal to 2.72. Our third step will be absolutely. Use the z-table to look up the area of the z-score you calculated in step 2. Z is equal to 2.72 has a corresponding area of 0.4967. How about step 4? Absolutely. Draw a normal curve and plot the z-score 2.72 in the x-axis and its corresponding area. Then, shade the part that you're looking for. The probability of x bar is greater than 47.5. Since we are looking for the probability of the mean time, which is more than 47.5 minutes, the shaded part will be on the right part of 2.72. After sketching the graph, what comes next? Certainly, subtract the corresponding area of the z-score 2.72 from 0.50. The probability of x bar is greater than 47.5 is equal to 0.50 minus 0.4967 is equal to 0.0033 or 0.33%. Lastly, we will state our answer. Thus, the probability that the 45 students will complete the periodical test in more than 47.5 minutes is 0.33%. Did you understand, learners?
Yay!
There you have it, learners. Now, let us try to answer the given problem by applying the central limit theorem. Proceed to number 1 for letter B, page 103 of your learning activity sheet. You will need a separate sheet of paper for your computation. I'll be reading the problem. Start answering. You are given 40 seconds to answer the given item. Here's the problem. The average time it takes a group of senior high school students to finish a periodical examination is 45 minutes. The standard deviation is 6.5 minutes. Assume that the variable is normally distributed. What is the probability that if 50 randomly selected will take the periodical test, the mean time will be less than 47.5 minutes? Alright, ballpens up. Check your papers honestly. Here are the answers for number 1, letter B. Step 1. Identify the given parts of the problem. Where x bar or sample mean is equal to 47.5, mu or population mean is equal to 45, sigma or population standard deviation is equal to 6.5, and n or sample size is equal to 50. Find the probability of x bar is less than 47.5. Step 2. Use the formula to find the z-score. Z is equal to sample mean minus population mean over population standard deviation divided by square root of sample size. By substitution, 47.5 minus 45 over 6.5 divided by square root of 50 is equal to 2.72. Step 3. Use the z-table to look up the area of the z-score you calculated in step 2. Z is equal to 2.72 has a corresponding area of 0.4967. Step 4. Draw a normal curve and plot the z-score. 2.72 in the x-axis and its corresponding area. Then, shade the part that you're looking for. The probability of x bar is less than 47.5. Since we are looking for the probability of less than 47.5 minutes, the shaded part will be on the left part of 2.72. Step 5. Add your z-score from 0.50. The probability of x bar is less than 47.5 is equal to 0.5 plus 0.4967 is equal to 0.9967 or 99.67%. Lastly, we will state our answer. Hence, the probability that the 45 students will complete the periodical test in less than 47.5 minutes is 99.67%. Did you have fun in the activity?
Oh, yeah!
Congratulations! That is the right attitude. Having an interest in making learning fun are some of the keys for you to understand the lessons well. With that, here is a quiz that shall challenge you. Be ready. However, let us have a short recall illustrating central limit theorem before we proceed. Can you define it? Indeed, central limit theorem states that the sampling distribution of the sample mean approaches a normal distribution as the sample size increases. This theorem says that regardless of the distribution of the population which a sample is taken, we can choose a sufficiently large n so that the resulting sampling distribution will approach a normal distribution. In general, n is greater than or equal to 30 is large enough for the sampling distribution of the sample mean to be approximately normal. Did you note that?
Oh, yeah!
And here is your quiz. Proceed to number 1 for letters C and D. Page 103. Let me read the following problems. Number 1, letter C. The average time it takes a group of senior high school students to finish a periodical examination is 45 minutes. The standard deviation is 6.5 minutes. Assume that the variable is normally distributed. What is the probability that if 50 randomly selected will take the periodical test, the mean time will be between 43 minutes and 47.5 minutes? And number 1, letter D. What is the probability that if 50 randomly selected will take the periodical test, the mean time will be between 46 minutes and 47 minutes? And that's the end of our quiz for today. I hope you were able to answer all the questions. We are going to reveal the answers in the next episode. After answering the quiz, please put your answer sheet inside your plastic envelope to avoid it from getting lost. Make sure that you submit your plastic envelope on the date of retrieval at the designated pickup points of your school. If you have any questions or suggestions, don't hesitate to contact your math teachers. Their numbers are written on your modules. The script for this episode was written by Hensley R. Marquez. Before we say goodbye, I want to share a quote saying, "Not everything has a normal distribution. The central limit theorem requires linear, additive behavior of the variables involved. Thus, the same goes in real life. It requires us to weigh our options carefully while making predictions in order to have wise and accurate conclusions." Again, this has been your radio teacher, Hensley R. Marquez, now signing off. To God be the glory for always keeping us safe and healthy.
Patuloy ang edukasyon para sa ating henerasyon.
Sa daan ng pagkatuto ay walang may iwan.
Kaya halina sa Radyo Eskwela.